So in yesterday's class, we were working on some work energy theorem problems. And since today is a short period, I kind of want to finish that up today. I want to get that done so that next week we can start looking at energy, conservation of energy, and hopefully finish up. Okay, at some point next week.
Are we gonna learn like any more like formulas or anything to
We will be using the formulas we have, m times g times h and 1/2 mv squared, in different arrangements, but not necessarily new formulas. No. Okay.
Is the 26th the Tuesday? Or I mean a Thursday?
I believe so.
I wish it was a Wednesday.
You get a 0 if you skip.
What if you add?
Okay, so give that one a try, guys. Write it down, put the diagram on there. Okay, the diagram is important. Okay, for what you're doing, you will need both of the numbers that are on that diagram. Okay, just to kind of get you started here. So if I roll something up a ramp, okay, what kind of energy am I changing about it? Doesn't mention anything here about speed changing, does it? What does it have when it gets to the top of the ramp it didn't have when it gets to the bottom? Potential energy, exactly. So this one here is talking about a change in potential energy. Okay, and guys, like, when you read through a question, if nothing is mentioned about speed, no speed numbers are given, then it's not a kinetic energy question. Okay? In this one here, we're just rolling something up a ramp. But what do they do give me right here? The height, the final height. What's the initial height?
0?
Right. Okay, so if we're figuring out our givens here, initial height 0 meters, final height is 8.2 meters. What does that make the 22 meters?
Distance.
Yep, it makes it the distance. That's where I'm exerting the force, right? I'm pushing it up the ramp. Okay, so my force is exerted over the 22-meter distance. Okay, maybe that'll get you started. So once we've identified, and this was a bit tricky to identify which type of energy was changing, okay? We have the change in potential energy being what's going on here. I'm looking for force, I've got distance, so when I expand this out, I'm definitely using force times distance here, okay, is going to equal the change in potential energy. So that's m times g times hf minus,
Minus times GH.
right, m times g times hi. Why did I not write that?
Because it equals 0.
Because it equals 0. Okay, I'm starting at the bottom of the ramp where I have no potential energy. So I am looking for the force, so what do I do with D? Divide it over to the other side. Okay. So force is going to equal, what did we say? It was 1.2 kilograms times 9.81 times 8.2 divided by 22. Okay, so we're going to be using 4.39 or 4.4 newtons worth of force to make this happen. Okay, and guys, very often if I don't use a bow and arrow for the potential energy one, you know, shot straight up in the air, okay, then I use a ramp. Ramps are my favorite. Yeah, we get to physics 20, like we spend a week on inclined planes.
Right.
So if you don't figure them out, you will be an inclined plane wrapped around an axis. Screwed. Think about it. It's true. It's a Sheldon Cooper joke. Okay. But yeah, if you have, if that's why a screw works. It's a ramp. It's easier to make it go in like that than it is to drive it in. You can. All right, try this one. This is the Cool Runnings question.
Have you seen that movie?
The original, yes. I heard
I
they made a
haven't
remake.
They're making a remake?
That's what I heard.
Cool
I mean, they
Runnings.
redid Eddie. They made a movie about Eddie the Eagle. They got to do the Cool Runnings again.
I love that show.
It's a good show. Yeah, nice wholesome movie.
Every time I watch it, I laugh. Wait, what?
Okay, so we got the bobsled team exerts a force of 800 newtons on a bobsled over a 15-meter distance. Okay, the bobsled accelerates from rest to 9.5 meters per second. What's the mass of the sled? It's the first time we've had to solve for mass. Okay? Sorry. Oh, okay. Oh, okay. What kind of energy is changing in this one? Kinetic, yeah. We've got acceleration, okay? We've got change in velocity. So work is changing our kinetic energy, right? Force times distance is going to equal kinetic final minus kinetic initial, but what's my kinetic initial? 0, it starts from rest, so I don't even need to bother writing that. I can just say this. Right. Now, for the first time, I'm looking for mass. So what do I do with the half and the VF squared? Divide them over to the other side. Okay, so that's going to mean then that I've got 800 newtons times 15 meters divided by 1/2 times 9.5 squared. Okay, so 800 times 15, okay, divided by 0.5 times 9.5, whoops, 0.5 squared. Okay, so the mass of the bobsled is 265 kilograms, 266 kilograms. That's kind of heavy. But if they were in it, it would be. No, because we're finding mass. Mass isn't squared. And that's actually something I was just about to talk about. You read my mind. Stop doing that. Okay. I'm just kidding. So if we're looking for VF, we have to square root because VF is squared. But if we're looking for anything else, it's not squared, so we don't need to square root. Michael, question? Well, I did, because it's all being multiplied here, so I divided the half over. Right, it's all in a row. 1/2 times mass times VF squared, so to move anything I had to divide. Okay. Any other questions on that one? Okay. How are we starting to feel about these? Are we starting to kind of get it, kind of get the pattern? Okay. I mean, really the trick here is to figure out which type of energy is changing. And I think we're starting to get the hang of that. The rest of it is just algebra. Okay. And yeah, I mean, algebra can be a little bit tricky sometimes, but you guys are pretty good at it, so shouldn't have too much trouble here. What was the other one I wanted to do? Okay, I'd like you to try that one because it involves like one of the energies, neither of them are 0. Okay, and those involve a little bit more algebra. Okay, just because there's nothing that cancels off completely. Okay, so give this one a try. Car applies its brakes with a force of 10,000 newtons. That makes it slow from 20 meters per second to 6 meters per second. Car's mass is 1,700 kilograms. You are looking for the distance that it travels. So let's have a look at this one. So if a car applies its brakes, and we know the force the brakes exerts are 10,000 newtons, and we know that it slows from an initial velocity of 20 meters per second to a final velocity, or speed, sorry, of 6 meters per second. And the car's mass is 1,700 kilograms. We're looking for the stopping distance, or not so much stopping because it didn't stop, but how far did it travel during the deceleration? Oh, and look at what I just did there. I used the term I'm not supposed to use in physics. Decelerate. Then during the negative acceleration. Okay, so the kinetic energy is changing in this question. Okay, and so we are looking at force times distance equals 1/2 mvf squared minus 1/2 mvi squared. Now, how many people when they did this got that number, but it was negative? Okay, so that's okay. But what other number in this should have been negative to make sure that that number came out positive, because that says when I apply the brakes, I go backwards. I accelerate backwards, but I don't go backwards.
I knew that it was supposed to be positive, so I committed
Okay, but what number in this should I make negative? One of these is a vector quantity, and it's not the speeds. Force. Your brakes exert a force backwards. That's why you accelerate negatively when you apply them. That's why you slow down. It's a force that's backwards. So this force is actually negative 10,000 newtons. So when we manipulate this to solve for D, we're left with D equals 1/2 times 1700 times 6 squared minus 1/2 times 1700 times 20 squared divided by negative 10,000. Okay, and that gives us a positive 30.9 meters as a result. Okay, obviously you guys probably looked at that number and went, negative, that doesn't make sense. It's supposed to be positive, just scratch it off. That's fine, as long as you recognize it shouldn't be negative, because that means you applied the brakes and immediately started going backwards. That would be highly unsafe. Okay, like that would really change tailgating behaviors in a hurry. All right, let's leave it at that for today, guys. Good work today, and on Monday I think we'll start looking at just energy stuff as opposed to work and energy.
Just